The name of this experiment is bulk density, void ratio, and porosity of aggregates. The aim of this experiment is to find the bulk density, void ratio, and porosity of the given fine and coarse aggregates in both loose and compact states. The apparatus required for this experiment are as follows: a balance, which is sensitive of 0.5% of the weight of the sample to be weighed, a cylindrical metal container having sufficient capacity as shown in figure, a tamping rod dimensions 16 mm diameter and 60 mm long, which is rounded at one end, and finally a measuring jar. The procedure of this experiment is as follows. The first step is to take the weight of the cylindrical metal container that we are using for this experiment and note it as W. We must also note down its volume as V. Next, we fill the given sample of aggregate until it's filled to 1/3 of its capacity, and we give 25 strokes with the help of the tamping rod. We must ensure that we are using the rounded end of the tamping rod here. The next step is to fill the container to overflowing by filling in the same manner as above in 2 steps. Now we must remove any surplus aggregate using the tamping rod as a straight edge as shown in figure. Now we must take the weight of the container with the aggregate and note it as W1. Then again fill the mold with aggregate without compacting using a tamping rod. The weight of this non-compacting aggregate is noted as W2. Now we can calculate the bulk density, porosity, and void ratio using the formulas given in the next slide. Observations and calculations. Firstly, we have to calculate the bulk density of the compacted and the non-compacted aggregate. Bulk density of compacted aggregate is given by gamma 1, which is equal to W1 minus W by V. Here W1 is the weight of the cylinder and the aggregate. W and V are the weight and the volume of the cylindrical container respectively. Bulk density of the non-compacted aggregate is given by gamma 2, which is equal to W2 minus W by V. Here W2 is the weight of the non-compacting aggregate. The specific gravity of the aggregate is given by G, which is equal to 2.65, which is already given. Percentage voids of the compacted aggregate and the non-compacted aggregate are to be calculated for the calculation of void ratio. So the percentage voids of compacted aggregate is given by x1, which is equal to G minus gamma 1 by G into 100. Similarly, percentage voids of non-compacted aggregate is given by x2, which is equal to G minus gamma 2 by G into 100. Now we can calculate the void ratio using x1 and x2. Void ratio of compacted aggregate is equal to x1 by 1 minus x1, and void ratio of the non-compacted aggregate is equal to x2 by 1 minus x2. Finally, we have to calculate the porosity of the compacted and non-compacted aggregate. Porosity of the compacted aggregate is given by 1 minus gamma 1 by G. Similarly, porosity of the non-compacted aggregate is given by 1 minus gamma 2 by G. The results that we obtain from this experiment are to be tabulated as follows. We have completed this experiment. Thank you.